Now we got the value 9.81 divided by 9.81, so that's going to be 1 gram per milliliter. Now if we are looking for the second part, which is specific weight and density of the mercury, now we got a formula. Specific weight of mercury, yeah, equals S of mercury and the specific weight of the oil. We got this value as 9.81. Let me use this one, 9.81. And for the mercury, we got specific gravity. They should be Sg, specific gravity. Specific gravity of the oil is 13.56. You multiply that one, and you will get a specific weight of the mercury, which is 133 kilonewton per meter cube. If you are looking for the density of the oil, the density of the mercury, yeah, we have the specific gravity of the mercury here, 13.56. Okay, so we got the specific gravity of the mercury, which is here, specific gravity of the mercury, Sg, which is 13.56, and the density of the oil, we take that one as 1. We got it from here. Multiply them together, and you got 13.56 kilonewton per meter cube. Let's say we got a cylinder, and diameter of the cylinder is here 0.5 meter. The height of the cylinder is here 1 meter, and we are going to fill that one with a liquid having a specific weight of 2000 Newton per meter cube. If you got 1 meter cube is 2000 Newton, 2000 force. Remember, this force we find by multiplying by mass times the 9.8. How many kilograms of this liquid must be added? So we got the diameter all the way from here to here, 0.5. We got the length from here to here, 1 meter. Yep. So we need to find out how many kilogram of liquid we can actually add in this container. Okay. Now, first thing is we can find out the volume of the cylinder. The formula for the volume of the cylinder is volume is pi r square, up to you which formula you use, h, where r is the radius. So it's better to convert that diameter into radius and use that formula rather than the diameter formula. This is a lot simpler. So that's going to be 0.25. Yeah. So put the value here. Let's call it lower r. Actually, let's call it uppercase r here as well. Okay, so we will get the volume. Once we got the value for the volume, you need to find out the weight. To find out the weight, we have an equation. Weight, actually we have a weight equals to specific, yep, we have a specific value which we got from here, the volume, multiplied by the specific weight. So specific weight, so this is from the previous formula. And that will be the weight. But the question is asking you how many kilograms. Now to find the kilograms, what we need to do is, once you got, we know W equals to mg, and we're finding the how many kilograms. So it's asking you to find out the mass. So we need to make m the subject. So m, which is mass, equals to W over G. W, we got the value 392.7 divided by 9.8, you will get around 40 kilogram. Let's look at the next example. let's say with these we got 1 liter of SAE 30 oil, weights 8.7 Newton. So that's the weight. I can find the mass. If I divide that by G value 9.81, I will get the mass. Find the specific weight. We need to find the specific weight. We need to find out the density. And we also need to find out the specific gravity. So specific gravity is that one. Density is that one. Specific weight is that one. Yep. Okay. Now the volume is given here. The volume is given here. We have the volume which is 1 liter. So the volume, we have the value for the volume. 1 liter. To convert 1 liter into meter cube, the conversion factor is 1 meter cube is 1000 liters. If you go 1 liter, 10 to the minus 3 meter cube. We have the weight, which is 8.7 Newton. And if I want to find the specific weight, it's the weight divided by the volume of 1 kilogram, or sorry, volume of 1 liter of that product. So 8.7 we got from here, divided by the 1 liter which we got from here, and that will give you 8,700 Newton per meter cube. Now after that one, if you want to find out the density, density is whatever value we got here divided by the 9.8. So you got 8,700, and this value is 9.81, and we will get an answer. So here the values are 9.8 I've used, but you can use 9.81. Now after that one, if you want to find the specific gravity, is oil, the density of the oil, which we got from here. This is the oil kilogram per meter cube. I think these are decimal is misplaced, so this one is going to be, this decimal is here. Yep. So if I correct this one, 887.755 divided by the density of water at standard temperature, which is 1000. So that is going to be 0.887 or 888 actually. Yep, if I round it off. And specific gravity has no units. Now we have a formula for the pressure. Now the pressure is just normal formula, force over area. But then we will convert this one into pressure by a liquid column, how much pressure is exerted by a liquid column. Now if we are looking at hydrostatic pressure, which is the pressure exerted by a liquid column, the formula is rho GH, where rho is the density We use all the SI unit. We have G as 9.8 or 9.81. And H is the height. Height of water column. Now we can rearrange the formula. We got rho GH. We got that formula. Now if we just put the rho, the density is mass over volume. So if I go in this equation and I say pressure equals to, instead of density, I put mass over volume and the GH remains here. The formula becomes mgh over V. Now if we look at the M and the G, M and the G is actually a W because W equals to mg. So the equation becomes pressure equals to WH over V. Now if we have a look at W over V, which is this bit, that's actually this. So we get this equation from here, and the equation will turn into gamma H. Now if you look at the pressure at the bottom of the column, so imagine you got a column of certain height, and you want to find out what is the pressure at the bottom. You can find out pressure here. You can also find out the pressure here, anywhere across the height. We got different ways of finding that one. We know pressure equals to force over area. Yeah, force is same as weight, the normal weight, because force is the force acting downward, weight is also the force acting downward. If I multiply the both side by V here and also divide by V, it won't make any difference. But if I just move this V here, it's weight over volume, and weight over volume is actually a specific weight. And this volume is the cross-sectional area. If I want to find the volume is actually a cross-sectional area multiplied by the height h. So instead of this volume, I just put that bit. Yeah. And then you can just cancel the A and the A. Once you cancel the A and the A, because this thing will cancel out, and you got pressure equals to rho h, which is here. So pressure depends on the specific weight, which is that, and the height. You increase the height, the pressure increase. You increase the specific weight. So for example, instead of water, you put mercury, the pressure will increase.